In today's video, I'm going to show you how we can take the new Unity default FPS controller and add a shooting system to it. So for example, if I hit play here, we can go around, we can shoot things. We have little particle impact points. If an enemy loses health, it will die. And obviously this can be a lot fancier. You can build on top of this, but the main thing that I want to do is take Unity's new default FPS controller and build this functionality on top of it, because I imagine many of you don't want to build your own FPS controller. You want to start from something, and Unity has provided something to us to work off of. So I want to show you how you can do that. It's going to be using the new input system, so you can see that down here. Work with how to do an action map and add our shooting to that. Also look at UnityEvents. So with our shooting system, I wanted to build it in such a way that you could actually reuse it in other projects. So you could come over here and see, we use our shoot and we put that on the player, but then on the things inside of our scene, we might have like a breakable wall. And on that, we'll have a shootable script that other things can plug into using UnityEvents. We'll look at how to do this through UnityEvents and to hook it up through code as well. And that way it'll be pretty robust. We can actually reuse a system. We can use it for enemies and shooting them and damaging them by subtracting health. You can open doors, you can do trigger events. It should be pretty reusable and flexible. So we'll build that on top of the default FPS controller, and I'll give you some tips and tricks on how to make it interesting and how to build on top of it after the tutorial is over with. So hope you stay tuned and we'll walk through how to do this. One other thing that I wanted to add here is that I know this is a really long video, and the intent here is that we're going to learn a lot about raycasting. I'm going to explain things along the way. I'm assuming that you're still learning new things, so we'll actually understand the concepts. Spawning visuals and sounds, UnityEvents, modular systems. There's a lot to talk about. So it's not just, getting a shooting system working. It's how can we learn how all these systems work so you can build on top of them. So I did want to mention that. I know this is a long video, but I really think you're going to learn a lot if you stick with it. So I'll try to break it out into different chapters so you can skip around if you like. All right, to start with, we need to grab our default FPS controller. And there's two different ways to do this. One is you can set up your project to include it by default. So if I were to create a new project over here inside of Unity Hub, you can see what version that I'm using. This should, I hope, be reusable in future versions. One of the options you have here when you create a new project is the first person core controller. And this will include everything we need. It'll include like a little sandbox map and the FPS controller. I believe it's in URP. So you can actually set up your project by default using this, which is what I'm going to do. But if you already have an existing project, another thing that you can do is you can actually just go to the asset store. I have it over here. You can find this on the asset store. It's starter assets, first person character controller, and you can add it to your assets. And if you have an existing project, it does have to be URP, I believe, then you should be able to import that in. I would imagine it works with HDRP as well, but I'm not positive. So in this case, I'm importing it into URP. If you want to do it in an existing project, you can, but I'm just going to import it by creating a new project. So I'm going to come over here. I'm going to, in my new project window, make sure that I have first person selected, give it a name, give it a location if you haven't already. We'll call this FPS shooter. And I'm going to do _URP just to make it clear what it is. And I'm going to click the create project button. And this will probably take a while. The newer URPs and HDRP versions of Unity import a lot of things. So this will take a bit. I'm just going to pause the video here. And once it's done, it should open up and bring you into Unity with all the assets that we want. Okay, so now that we have our new project set up, I want to give you a quick overview of the assets that are included in the first person template that we just imported. Before I do that, I'm going to set up my workspace just because it's how I am used to working, and this may take a bit. So just to show you what I do is I go to the top right where it says default, and I want to set this to 2x3. I take my project window and I drag it down on the bottom just like that. I also take my little thumbnail size thing and I slide it all the way to the left. And then I also click on the little 3 dots over here and I go to one column layout. So this is pretty much a browser at this point. One other thing that's super important to do is for your game window over here, click the little drop down to free aspect and change that to 16:9, or 16:10 is probably fine too. But one of those two, I'm going to choose 16:9. And the reason is because we want to preview what it will actually look like in the game, but free aspect view will just make it the size of the window and it's not what it'll actually look like. So make sure you're at 16.9, and that should be all our setup for our Unity layout. So next I want to look at the assets that we have. Just to show you real quick, the main things I want to look at are the input system over here. If you want to deal with the new inputs and adding new inputs to our player, we would go to this little starter assets over here. We would click edit assets and we can see what is being controlled over here and what's being called and all the different actions inside of code. So we'll look at this a little bit later, but if you wanted to add more inputs, this is where you would do it. Additionally, you'll see other things like scripts and prefabs over here that are related to the first-person controller. You can find that we're actually going to build on top of this. We're not going to do any editing on the basic scripts. So what I'm going to do is I'm going to take all of this and I'm going to put this inside of its own folder. I'm going to show you why in a second. First, I'm going to go under Assets and I'm going to right-click and say Create. I'm going to say Folder. And I'm going to call this Starter Assets. I'm going to take everything that we have so far. I'm just going to click and shift-click, drag it in. Click, shift-click, drag, let it recompile. We're going to drag it in. So I want everything underneath starter assets. It can become a very tangled web of stuff, and you want to be able to isolate what is the starter assets and what are my assets and what's this other third-party assets that you want to work with later on. So I like to keep those separate at the root so that if I ever want to re-import things or just know what's mine and what's not, that you can actually do that. So I'm going to make a new folder up here. I'm going to right-click and create folder. I'm going to call this _game. Now, anything that I add to my project, I'm going to put into this folder, this _game. The underscore is just so it puts it at the top so it's easy to find. So now that we have our project hierarchy, let's look around and see what we have inside of our map. This is our playground. This is our default scene that it included with the starter assets. So inside of this scene, you're going to see a player capsule. This is our actual player inside of the scene that will move around. If you look on that player capsule, you'll see lots of components like a first-person controller. It's using a character controller component and not a rigid body. So important to know if you're planning to do any other manipulations on this thing. There's also, pushing, there's other starter assets. This player input is related to using the inputs defined in our starter assets with the new input system. Again, you don't really have to worry much about this. We'll build on top of this. If you wanted to set it up from scratch, that would be a separate tutorial, and we're not really worried about that level yet. You can see some other things related to player movement and whatnot over here, but this is where all the player movement happens on the player capsule. You also see a main camera. We'll add like a weapon to this later on. And I think that's the main thing. It's also using Cinemachine. So this virtual camera that's following around, it is important to know that we're controlling everything through Cinemachine. So that's worth knowing. And that's about it. I mean, past the player, the camera, and the new input system and Cinemachine, as long as you know that we're using those systems, then we can keep moving forward. Okay, so the first thing I'm going to do is actually just for fun and visuals. It's not really in code. I want to make a little visual for the weapon that my player will be holding. Now, this doesn't really have to be a weapon. Yours could be a spell casting thing, so it could be like a book, or it could be a little hand or whatever. But we want some kind of visual to put in front of the player in case you have multiple different kinds of weapons. You may want to swap them out and so forth. We're not really going to get that far, but just to get that setup going so that you could expand upon that if you want. So to do this, I'm going to show you how to do it the quick way, and then I'll talk about why you may want to do something more complex later on. What I'm going to do is I'm going to find my main camera in the scene. I'm going to right click and I'm going to create empty, and I'm going to call this weapon socket. And I'm going to position this. Now, the reason we're doing it this way is if you had multiple different weapons inside of your game, you want to be able to position your weapon at the same hand point. So if you had a skeletal structure, you could put this on the bone on the character. But for now, we're just going to define a point in front of the player that we can parent the weapon underneath, and we'll just, we're not going to switch ours out. But I think having the setup as a starting point will allow you to expand upon it later on. So we'll call this a weapon socket. We're going to pull this out and position this now. You can just do this in your scene right here. I think it's important to note over here, this drop down, we want to make sure that this is set to pivot and not center. Otherwise, we're not really tracking our actual pivot. Like, it's accurate right now, but once we start adding more objects, it won't be. So make sure that you're set to your pivot over here with that setting, so we can actually see what the pivot is. Another thing I'm going to do is this little, at the top left of the inspector, click that drop down, and I'm just going to give it a little diamond or something. That's fine, little yellow diamond. And this will just allow us to see it inside of the scene. So now when I position it, I can actually see where it is. My settings for what I have is, I think it's 0.3x, negative 0.3y, and 0.6. Something right around there. Like you'd imagine this is where the hand is, and you could adjust this later. Now, underneath the socket is where I'm going to create my weapon. Now, if you had a weapon mesh, you could just take that whole weapon mesh and just put it underneath the weapon socket. But, for me, I'm just going to rough something out with primitive shapes. So let me show you what that would look like. I'm going to right click, I'm going to create another empty, and I'm going to call this weapon. Underneath that, and this is empty, right? This is underneath the weapon socket, which has transforms, but the weapon has to have 0, 0, 0. The reason is so that we can put the pivot on the weapon at the handle so that we could actually hold it on the handle. On the weapon, yours may have a mesh on it, and that would be fine as long as your pivot is set directly. But for me, I'm going to build a little weapon out of primitives. I'm going to make those child objects underneath the weapon. So I'm going to right click my weapon, and this weapon visual is going to be a cube. Let's say, we'll rescale that. And because my parent doesn't really have any transforms, it doesn't really matter what our, visuals underneath the transforms of this will look like. Now, the other important thing is I need to remove the collider from my weapon. So for me, since I'm using primitive shapes, it comes with a collider by default. So I'm going to remove like that. Do not forget to remove the collider. Another thing I'm going to do is I'm going to pull this up a little bit. I'm going to add a material onto my weapon. So under here, under my _ game assets, I'm going to collapse the starter assets just so you can see this. I'm going to come to my game assets, right click, create folder. I'm going to call this materials like that. I'm going to right click materials, create a new one, material, call this m_weapon. I'm going to give this like a blue, something like that, on our base. And I'm going to apply this weapon just by dragging and dropping it onto the weapon, just like that. All right, so now I can take this and I can position it however I want. I can scale it out. I can do like this. All right, that's pretty good. Move it down. You can see that I'm looking at my camera right here to see what it looks like inside of my view. I can move it over here. I may want to make sure that this is centered. If I'm holding it on that pivot right there, I'll pull that forward. I may want to make a handle, so I'm going to Control D to duplicate. I'm going to flip it around, and you can be really loose with this too. It does not need to be perfect because we're just doing this for a prototype. Theoretically, we could import actual art later on. So get a little handle, pull that up a little bit, right? So this is our weapon. Again, make sure our weapons are 0 transforms, but we're going to, shift this around so it looks correct in our scene. It's pretty good. Let's make this a little bit more complex by taking our weapon barrel over here. We'll shrink that in. We'll Control D to duplicate. We'll give it a little thing at the front, make it look a little bit fancier, something like that. You can press F to zoom in, scale it in. All right, I'm going to duplicate that again, pull it down. We'll scale this out. This part doesn't really matter. You can make it look however you want. Just give it some kind of look. Scale it out a little bit. And remember, super important, none of these objects have colliders on them. So make sure you double check that. And then one last one, duplicate it up here. Oop, kind of like that. Pull it forward, pull it down. Do I like that? Yeah, that's all right. Pull that forward like that. All right, now, that could be fancier. Again, if you have an actual art asset, you could import that in, but I think that's good enough for prototyping. I'm gonna make one last little change here. All right, I think that's pretty good. So this is our weapon. Now again, no colliders on any of these objects. They're all child underneath the weapon. This weapon could theoretically be a static mesh that just has all of this instead of the child objects. So you could re-import that later if you like. So I have this weapon. Weapon has 0 transforms, meaning that the pivot is right at the socket right there. So if I hit W, you can see it. So if we were to turn on and off our weapon, you can see we're equipping, right? We're grabbing a new weapon. So we're all good. Our weapon socket does have transforms, and that's fine because we do need to position our weapon socket. But now, whenever I Control Save and I press play and I look around the scene, you can see that our weapon follows our camera, and then we can do other stuff with that. So just a little fun visual to add, which you can replace later on, but I think it does really make the prototype feel a lot better. So I wanted to do that at the very beginning. Now, for our prototype, there are 2 different objects that I'm going to experiment with just to give you some examples. I'm going to go ahead and make those now. I'm going to make a destructible wall that just turns off or breaks, or you can get fancier with it later. We're just going to destroy it whenever it's shot, and we're going to have an enemy that's just going to take damage when it's shot. Again, you can build off of that, after the tutorial, but let's make those objects here. So I'm going to make a new game object, 3D object cube. I'm going to put this over in the doorway over here. These starter assets, like this environment might change, doesn't really matter. Just make some kind of wall, position it. I'm going to put it in front of this little open space so that we can break it and walk inside. All right, something like that. And then let's make sure to give this a name. We'll call this breakable wall. And in addition to that, I also want to make an enemy. So let's just make a new object, 3D object, capsule. Put this enemy down here. We'll call it enemy. And we're also going to give it a material. We can actually get both a material. Let's go down to our materials, right click, create material, m_enemy. We'll drag and drop that on, make it red, orange, or something. Yeah, that's fine. And we'll also make a breakable wall. Make a new material. Breakable wall. Okay, it's typically good to make associations in terms of game design and gameplay. So if something is shootable, we want to stick with a certain kind of color palette, or give it a cracked texture, give some kind of visual indicator. Sometimes we would call this a signifier. So I would just make your color somewhat consistent. Doesn't have to be perfect, but it should be similar enough. So like similar. All right, that's fine. We want to communicate to the player that this is shootable with our visuals. So now that we have our objects created, we can start to build our shooting system and add the functionality. Now we're going to begin building the functionality. So the first thing I'm going to do is I'm going to create a script, and I'm going to call it shootable. This is going to be a component that we can add on to any object in our scene that we want to be shot and have some kind of response to it. So inside of my project, I'm going to right click, create, C#. I'm just going to call this shootable. And I'm going to come up here and I'm going to drag the shootable script onto my breakable wall. And I'm going to drag the shootable script onto my enemy. So breakable wall, shootable, enemy, shootable. You could have other things be shootable as well. Now, the reason why we're doing it this way, technically you could do this with something called an interface and attach it. But I actually like doing a component-based design like this with, modular components, shootable, damageable, whatever. Because it's more reusable, you can just add this to any game object in our scene, and now it has new functionality. It's just very designer friendly, I think, to do it that way. But you may have your own preferences. You could do this the more complex, interface version as well. In our system, we're going to have a shootable component that we will test whenever we eventually put it in our shooting. And if this object has a shootable component, we'll run an event on it and we'll do some response. So I'm going to open up this script that we've attached to both our breakable wall and our enemy. So I'm going to double click and open it. And once this opens, I'm going to start adding my code. So I'm just going to get rid of this default stuff. All right, so the way that this is going to work is our shootable component is going to just sit there and wait, and it's going to receive a shot. And so at whatever point it receives a shot, it's going to respond by triggering an event saying, I've been shot. And then anything that wants to know about when this thing is shot can respond and, like take damage or disable or whatever. So the way this is going to work is we're going to use something called a UnityEvent. And in order to use a UnityEvent, we have to add the namespace at the very top. This is called a namespace. So I'm going to say using Unity engine.events. Now, if we add this, now we can create the event that we can trigger that other things can look at and respond to whenever this thing is shot. So I'll say public, this is a type of Unity event, shot, just like that. Now I want to show you something real quick. If I save it and I come back into the inspector and I let that recompile, you can now see this little box. Now, if you've worked with UI at all inside of Unity, you'll recognize this as being similar to an on button click. It's the same thing. It's just saying, when I trigger this shot method in my own code, anything that subscribes, and I can add new things and drag them in and have them respond, will actually run their own method. So when this thing is shot, I can add a thing and then just drag in an object in the level and tell it to do something. I could disable an object in the level. I could open a door. I could take damage. I could do whatever. So that's how our system's going to work. But in order to actually call the things that are hooked into that, I actually need to call this Unity event somewhere inside the script. So I'm going to come down here and I'm going to make a public method. I'll say public void shoot. And when this method is run, when I say shootable object dot shoot, then I'm going to invoke my Unity event. So I'll say shot. I'm going to do a null check here by adding a little question mark. This is just saying only run it if it's not empty. Invoke. Like that. And it sounds like weird, nonsense language. But when this shootable object dot shoot is triggered, so when something else says, hey, shootable dot shoot, then this thing will say, hey, I've been shot. And then anything that wants to respond to that can. So this is our system, pretty modular. You can take it into new projects and you can reuse it. But once we do this, you can now see that we can hook in things to happen when this thing is shot or when this thing is shot, but it's never going to actually trigger until we actually shoot it. And then it can actually receive that shot. So I'm not going to explain that too much further until we get the rest of our system working, and then I'll show you how this plugs in. So we're going to actually build a system that shoots a raycast towards a door. It'll test the door and say, hey, do you have the shootable component? If it does, then it will run all these things in response. Now we're going to look at how we can add a new input using the newer input system on top of our FPS controller that we imported so that we can add a new action and then, trigger that input inside of gameplay. So to do that, I need to go back into my starter assets down here. I'm going to expand input system and I'm going to go to starter assets. And this is my input action asset. So go to this one right here. Maybe it's called something slightly different in the future. Don't really know, but it's going to look like this, and click edit asset. So right now you can see all of the inputs that are defined inside of our new input system action asset. And we want to define a new one. You can see there's jump, there's move, there's look, whatever. This is also cross controller compatible. So it can work on a space, on a keyboard, or on a gamepad. We're not really worried about that too much now, but we could always expand it easily if we use a system. So I'm going to make a new one, just like jump, it'll be a new press the shoot button. So on my actions column right here, there's going to be an arrow at the very top right. This is going to add a new one. So I'm going to click that. My new action is going to be called shoot. And you could add other actions later on if you wanted to expand on this, like equip or switch weapon or whatever. Now, this is my action. In order to listen for a particular controller input, I need to define one right here, and that's going to be my binding. Now, on this binding, I'm just going to do this on my left mouse button. So on this one, we're going to go down to mouse. We can find left button right there. So when I press the left mouse button, it's going to shoot. We can actually define a control scheme here. Not going to worry about that yet. So that's all we need. We created a new action inside of our input asset, and we assigned it to a button. So before you close it out, make sure you hit save asset because it doesn't autosave by default. Click save asset and close it out. Now we have our input added to our action mapping, but we need to actually call it on our player. If you click on your player capsule and you scroll down, this player input component is what allows us to talk to the input assets over here that we were just working with. And by default, it's using something called send messages. I'm actually not going to change the default because we're building on top of a system. I don't want to rework what they already have here. But the way this works is that it will trigger any method that has these names down here that you can see at the bottom. And one of those, which we just added, shoot, so it's going to be called on shoot. I'm going to show you something else. If you want to see the syntax and where we're getting it from, if you come up here and you click on the starter assets inputs and you open that up, you can see these ones that it already has defined over here as public void on move, and then it has input value. If you want to see it pretty similar to what we're trying to do is on jump. So if we make a public void, and for us, we want on shoot, if we want to, receive that message, we want to pass it input value, just like that. So we're going to put this in our own script, which we're going to create next, but this is how we would receive it. And I'm going to go ahead and do that. Let's create a new script, and we're going to call this C# script inside of my _game folder, and we'll call this use shoot. Again, this is going to be a separate component. We're going to try to keep it modular and separate. And we're going to attach this to our player. So we go to, let's see, player capsule, scroll down to the bottom, just drag and drop my use shoot new script that we just created. I'm going to open this up, save it. And because this script is on the same game object as our player input, it's going to receive this onShoot method if we build the syntax correctly. So it's going to be onShoot. Let's open that back up. Get rid of all this. And we just want to make sure that this works before we keep going on. So we can look back as a reference example. We can find our, where is it? Our onJump right here. We'll copy that. We'll get it here and we'll paste. So our uShoot. Now we want onShoot with a capital S. It's going to take the name of our action and add a capital O for on, and then the name of our action right there. The reason we're getting a red squiggly right here is because we need to actually add the namespace for the new input system at the top. So using Unity Engine .input system, semicolon. And the last squiggly that we have is, this doesn't really exist. So we're going to remove that part. So we should receive this message right here. And we're going to do one little if statement just to make the final call for this. We'll say if value, which is this parameter that we're passing in right here. This is going to look a little bit weird, but honestly, their new input system has a lot of weird syntax up front, and then the system pretty much works after that. So we're going to take our value and we're going to say dot is pressed. And if it is, then we want to shoot, right? So we'll run a new method called shoot. Down here, we'll call this private void shoot. And then we can test it by adding a debug.log. Shoot. Okay, so theoretically, as long as we can see this debug.log, it means that we're receiving our input correctly. We're actually testing and we do see that it is pressed, our value that we defined, and then it'll run this method and then we can see it. So if we see this, we know that we're good and we can continue. So we want to test that first. Make sure that we are doing our input correctly. And I think that'll do it. Let's go ahead and save this and we'll come back in here and we'll test it out. Save our scene, hit play. And down at the very bottom left corner, you can see the little shoot. I'm actually going to use this opportunity to open up our console because we're going to need this later. We'll use our console. I like the docket next to the project. Hit play. And then every single time we press the left mouse button, it is shooting. So we know that it's working. So now that we have our input set up, we just need to build the functionality to do our shooting. So at the very top, there's a few things that I know I'm going to need. You could figure this out as we go along, but I think it's just useful to just put it up top so we don't have to worry about it later. One thing that I think I'm going to want is the ability to separate out some things that can be shot and some things that cannot. We may want enemies to be shot, we may want walls to be able to be shot, but we may not want to be able to shoot clouds, for example, or sprites or triggers or whatever. So I think I'm going to need to set up a layer system so that I can ignore things if I like. So I'm going to do that up here. So I'm going to say serialized field. I'm going to show you a little trick here. I'm going to use something called a layer mask, but I'm going to give it a default. That will mean I can shoot everything by default, and then I can tell it to ignore specific things. So to do that, I'm going to say serialized field private type of layer mask. I'm going to say underscore layers to shoot, just to be really clear what this is. These are the layers that will be affected. And then I'm going to give it a default of -1. And this just means that the default value will do this weird bit shifting stuff, which you don't have to worry about. But if you default it to -1, that will essentially make it default to everything, whereas the normal default is nothing. And I find that kind of annoying. I want to default it to everything, and then the designer can decide the things that they want to be shot or not. So if I save this and I come back, let me show you what this looks like. Scroll down, you can see we just added this and it defaults to everything. But if we want only certain things to be shot, we can pick and choose and enable and disable things that we want to be shot or not. So that's fine. Other things that we need to specify, we may want a shoot distance. So we'll do a serialized field, private, float, shoot, capital D distance, default that, some large, 30 is fine. You want to be able to control that though, not infinite. And the last thing is because we want to shoot from the center of our camera is usually the most accurate. The way that we're going to do it is like raycasting and a line trace. We want to shoot it from the center of the camera. That's typically what the player would expect. You can do some fancier things to connect it to the muzzle if you want, but I'm going to keep this real simple. Serialized field, private, type of camera. And we could find this, we could do a scene search or whatever, but since the player already exists in the scene, we can just plug it in. I'm going to go ahead and hook that up right now just so I don't forget about it later. But if I scroll down here, I'm going to collapse some of these other ones just so I can see what I'm doing. There we go, much better. Okay, camera, we're going to find the camera. That's our main camera. We'll connect that in so everything else is connected how we like. Save our scene, we'll come back. And now it's actually time to talk about raycasting. So raycasting is kind of interesting. Essentially what we want to do is we want to create a line at the player's camera position, right? We'll do it like where the camera is. We'll create that line and we'll extend it outwards, and we want to shoot a ray in a direction. We'll just do forward direction. We want to shoot the ray, and we want to detect the first object that it hits. So let's say that this ray comes over here and it shoots and it hits the enemy. We also want to know the exact point on that collider that was hit so that we could create a spark at that point. So in order to do this, we're going to draw our ray with the physics system. We need a start point. We need to calculate the direction, which is just going to be forward direction. We need to calculate the distance, which is direction times an amount. So if we have our direction, our distance is going to be a length of 30. So we're going to create that line right there. Then we're just going to say, hey, what does that ray intersect with? And we're also going to filter out everything that's not in our layers. If it intersects with the enemy collider, then we'll say, hey, we can do stuff. We can check components. We can spawn like a spark or whatever. And we'll do all that stuff later. But the important thing to understand is the raycasting portion is we're going to draw that line, the start point, we need to calculate the end point, and we need to do that with the distance and the length. So we'll do that next. Come back into our script, and we'll do that right here, undershoot, because we know that we can get this far because we've gotten the console message. I'm going to be very, overly verbose about this. I'm going to create a lot of extra little things just so that the syntax is super, super clear. There's ways to condense it to be a little slightly more efficient, but in this case, it's more important that the code is readable so you understand the concept than it is about, crazy, weird, complex syntax that's sufficient. So things that I know that I need. I need a ray start position. I'm going to call that ray start pause. I need a vector 3 direction. So I'll call that ray direction. And I'll figure out both these right now. So our start pause, we want to be at the position of the camera. That's the start of the ray. We want to be wherever the camera is. That's where we want the ray to start. So we know that we're getting the camera component up here. And when we have this camera component, we can actually get the transform from that. So I'm going to say camera component dot transform and get that position right here. So we'll do that in code to get the transform position of the camera. So we already have the camera component because we dragged it in earlier. Dot transform dot position. Position of the camera, that's the start of the ray. We also need the direction, and that's just going to be the camera's forward direction. So the shortcut for that is camera.transform.forward. You can get that automatically very easily. Now let's preview what this looks like inside of our scene. To preview this, we can actually create something called a debug draw ray. To do this, it's called debug.drawRay, and then it's looking for something. So we want to give it a few things that it needs. So it needs a start position and an end position in order to draw this correctly. Our start position is going to be our ray start pause. Okay, we'll do a comma for our second parameter. Now it says direction, but what it really wants is an end position. I don't know why it calls it direction. But if you want to get an end position, we have our starting point. A direction times a length will give us a position at the end point. Right? So we're just lengthening the line at that direction in our scene. So I'll show you what this looks like. It's ray direction times a length, and that's just going to be our shoot distance. So we'll come up here. So direction times an amount gives us a line in a direction at a certain length. There we go. Now this is going to draw a line inside of our scene view. And if we want to be able to visualize it, we can also give that line a color and an amount to stay active. So I'm going to hit another comma here. I'm going to do a line break just by pressing enter. I'm going to say color.cyan. That's going to be the color of the line. And I'm going to do another comma. I'm going to make it exist for 1 second. I think that's reasonable. So comma 1. All right, so this is our debug draw ray. So if I save my script and I come back into Unity over here, I'm going to move my camera up here so I can see what I'm doing. Hit play. You see how if I shoot in my scene, it's drawing lines now. The length of that line is going to be my shoot distance. My direction, you can see it's just wherever direction the camera is facing in. but this isn't actually doing anything. This is just debug draw ray. It's visualizing something using a gizmo inside of the scene view. So I actually want to take this now that I know what it's doing, and I want to add functionality. Now you may ask, why am I even doing the debug if it's not really adding functionality? I will tell you, whenever you're working with raycasting, you're going to get so many bugs because you're, trying to do this all through code without actually looking to see what it's really doing. Like maybe you're casting it in the wrong direction. Maybe your distance is super, super short. I almost always end up creating a debug.drawRay, and it's going to make debugging so much easier. You can always comment it out and then, reactivate it if you want. I highly, highly recommend doing a debug.drawRay every single time you do raycasting. It's just going to help so much. But that's why we did it that way. All right, so now that we can visualize our rays, let's actually add some functionality and do an actual raycast. So come back into your code over here, and we're going to do a test. We're going to say if. Inside of our if block, we're going to cast a ray, and if it hits something, it's going to run the if block. So the syntax for this is going to look really crazy, and I'm gonna walk through this with you because we're going to do the more complex version of raycasting that involves layer filtering and whatnot. Our syntax is physics.raycast. Now there are a lot of different ways you can raycast. The way that I'm going to do it, first we need a starting point, which we already have up here, so I'm just going to copy paste that. So starting point. There we go. By the way, if you want to see more information about this so that it doesn't feel like I'm just adding it out of nowhere, you can actually open up the Unity API. Let me get that open for you. Right, I just type in scripting API, physics raycast. It'll give you some example code, but you can see it's very complex, and I'll explain this as we go, but you can actually find out, other examples and what's going on here in the API. All right, so we need a starting point. We need a direction, which you can see we already have. So we're going to, reuse it because we're also using that in our debug. Now, the next one's kind of weird. It's something called out hit info. And we can actually give this a name. We can call this whatever we want. What this will allow us to do is get additional information from the raycast. For example, what object was hit or where was the impact point on the collider. And I think that's going to be pretty useful. So I'm going to create a new little local variable up here right above raycast hit. I'm going to call this hit info, semicolon. Now, the only important thing is that this name is the same. I just always call it hit info just because it's descriptive, but make sure that that name is the same. Otherwise, it'll give you a squiggly. Another comma and do a break. Now, what this out means is it's looking for a variable to store this information that it receives from the raycast into. So it's just going to take the extra information and put it into this variable after the raycast is done. So then we can reuse this and get like impact points and stuff. I'll show you that in a second. Next, it needs to know the length of the raycast. So we have that at the very top, shoot distance. I'll copy that, paste that in. All right. And then the last thing it needs to know is because we want to do layer filtering, our layer mask, we don't want to be able to shoot everything. We want to be able to decide what we do want to shoot and what we don't. I think this is the proper way to do raycasting anyways. So I'm going to get the layers. Remember, the designer defined inside of the inspector what they want to be shot and what they don't. Copy that and just say, these are the layers that I want you to shoot, okay? And the last thing is we're going to do our brackets. All right, that was kind of crazy, right? Like this all looks kind of nuts, but we talk through it one step at a time. So hopefully that makes a little bit more sense. The next thing I'm going to do is I'm going to move my debug.log down here, just so that I can verify that my raycast is actually hitting something. Because if it hits something, we're going to run this block. If not, then we're receiving the input, but we're not actually going to see the debug.log because the raycast is not going to hit anything. So I want to test now before I continue to add functionality so I can catch any bugs that might have happened up to this point. So I'm going to save it, and I'll hop back out, and I'm going to come to my scene, I'm going to hit play. I'm going to keep an eye on my console while I'm doing this. So I'm going to click over on console, click back on our scene. You can see we actually do get our debug message. Shoot, shoot, shoot. If we shoot into the sky, we do not, right? So we're shooting, but we're not actually like receiving the hit with anything. So this is our raycast. So we can actually visualize that in the scene view as well. Anything that's inside of the specified layers, in this case, it's everything. If it has a collider, and it's in the way of the ray, that it will get shot. So we know that this is working so far, which is great. This is most of the hard work so far. Now we just need to connect our shooting system with our shootable script, but we're actually going to add a few other things as well. Okay, so before I continue and, connect this, I think it would be useful to have some audio and visual support just because it feels nicer and it, we can keep our motivation for completing our little mechanic. I want to have a little impact spark at the point that we shoot just to really show you the power of raycasting. And I just want to have a little like shot sound so that I'm communicating to the player, hey, you actually used your weapon. So I'm going to do a sound effect and a particle effect so I can show you how we can use feedback systems with visuals and sounds to improve the feel of your mechanics. Now, in order to do this, I'm intending to provide a link to you to, some assets you can use, but you can use your own too. I have other tutorials. So for example, this triggering impact particle tutorial, it's a little longer, but I'll show you how to make a little spark. I'm just using something very similar with that. And I just already have it made if you don't really want to do that. So you can import that. Let me show you, drag my asset in here. I'll drag it in, just import. It's using the particles emitter system, just like the other tutorial. And I also have some audio that were just made with the Chiptone website. You can just make some simple prototypey stuff. It's not fancy. Again, you can import your own audio. You can import your own impacts, particles, and it'll be set up in a very similar way. So I'm going to import, or you can make your own from scratch, right? Get more practice. So we're going to start off with the easier of the two, our VFX Shoot Spark. Now, if you made your own, I would tell you, make your game object in the scene. You can see what this looks like. I just dragged and dropped it in. If I hit the play button, this is what my impact particle will look like. It may be a little choppy just because I'm recording. But if you take your impact particle, the things that I want to make sure that you have checked is the play on awake. Make sure you have that checked. And right here, the stop action, destroy. This is saying once this is done, I want to destroy it. This means when we spawn it in the scene, once it's done with the impact, it'll destroy itself. Now we're going to do instantiation and destroy, which is not super optimized. Again, I'm trying to keep things real simple. An object pooling system is more complex. You can always improve the system, but this will just get the basics done. And it's fine for prototyping, honestly. So destroy, play on awake. All right. I also have an emission, like a burst style. As long as you have a short cycle, it's probably fine. So this is what mine looks like. Hit the play button and it bursts out. I'm going to make sure that that's a prefab because we're going to spawn the prefab at runtime. So I'm going to delete mine because mine's a prefab, but you just drag and drop and create a prefab down there. So it's no longer in the scene. So in order to actually spawn that, we're going to come into our script over here, our shooting script, which I lost track of. Here we go. And I want to show you how we can use this hit info. Now, the first thing we need to do is we need to get access to the particle system prefab that we want to spawn. So it's going to be a serialized field, private, particle system, because I'm using the particle system component. If you're using the visual effects graph, it would be a bit different. But again, I'm trying to keep things simple. We're going to call this impact particle. All right, now let's save that. We'll come back into the inspector. Okay, our script here is looking for a type of impact particle system. So that's our VFX Shoot Spark that we made because it has this particle system component on it. We're going to take our player capsule. We're going to drag our VFX particle spark in, just like that. So it has a reference to our prefab particle system, but it doesn't exist in the scene. We're going to spawn an instance of this particle system into the scene at the impact point. So we'll open it back up, make sure that this is plugged in. Okay. So when we shoot, we're going to say, so if impact particle is not equal null, meaning that we actually plug something in there, we're going to instantiate, in other words, spawn an instance of this prefab into the scene. And it's looking for a few things. It's looking for what is the prefab that you want to spawn. And I'm going to point it to our impact particle. So the reference prefab that we have up here, comma, and it wants to know at what location and at what rotation do you want to spawn it. So at the location, we want to get our hit info. If I copy this here, if I say dot, you can see that we get access to a lot of things. We can get access to the collider of the thing that we hit, the transform, the rigid body, like a lot of other stuff. But what I want is the point, and this is the point at which the other thing is hit. Hit info.point is going to return the position in the world on the collider. So that would be the difference of like, if you spawn it at the object's position, it'll be in the center of the object that's hit. But if you use the point, it'll spawn it, all the different parts of the body that it's hit. The collider, whatever. All right, the reason it's giving you an error is because if we use the position like this, we need to give it one more argument, which is the rotation. I'm just going to say quaternion.identity, which is essentially just saying whatever the prefab is. Do a line break there just for readability. All right, so if the impact particle is not empty, then spawn it. And when we spawn it in the scene, when this thing is created, remember, it will play on awake and destroy itself when it's done. So we don't have to worry about it. Just spawn and it'll handle itself. So let's try it out. Let's hit play. Check your references. Make sure you linked it all in. You can see all the locations where our Raycast impacts our collider. You can see that it actually creates a little spark effect, which is pretty cool. You could also spawn decals if you want, which could be kind of useful. But I'm not worried about that, right? Like, we're going to keep this simple. You could always build onto the system even further. Okay, so we're also going to make a shot sound, and you can find your own audio sound effects. I just went to chiptone and output some, but there should be some provided in the link as well if you just want to use mine. Totally fine. Just prototyping sounds are not great. You can replace those later. But I want to do the same thing that I did with my particle system, which is spawn it into the world and then destroy it when it's done. The thing is with our audio source system that Unity provides, it doesn't, as far as I know, have an auto destroy while done, but we're going to set it up in a very similar way and we're going to destroy it ourselves. So the way to do this is you're going to create your audio source and your scene. Now you can see that I provided a prefab already set up for you, but what you could do is you could create a new game object. And if you want to set this up from scratch, you create it in the scene, you make sure that play on awake is checked, you give it a clip, like an audio clip sound, you make sure that it's set to 2D because we want to hear it from all around, not looping, and I think this is all you need. By the way, I forgot there is a method that you can use with audio source called play clip at point, but at least as of now, there's no play clip at point in 2D. We want to be able to hear the gunshot. If we're moving really fast, you don't want to hear it behind us, right? So we want to hear this in 2D space, and play clip at point is useful for 3D, but not for 2D. So I'm just going to spawn mine in the scene for 2D just to make sure that they're consistent. Again, as just prototyping, easy, and build a more robust system later once it works. And then we could call this whatever we want, shoot sound. And then I just made a prefab out of that. So I have my own down here, which is the same thing, but that's how I made it. Key point here, make sure that once it's a prefab that it's deleted out of the scene like that. All right, so because we want to spawn it into the scene whenever we shoot, and then we want to despawn it. So let's take a look at that. We're going to go back into our shooting script, our use shoot, and just like our impact particle, we're going to make a new serialized field, private audio source. Call this shoot sound. Okay, we take our shoot sound, we come down here. If, just like before, if our shoot sound is not empty, not equals null, then we want to shoot. Now, this one's a little tricky. We can just instantiate it, but it doesn't destroy when it's over. So I'm going to do a little trick here to show you how you could do that. The trick is when I spawn it, I'm going to store it into a local variable that then I can use to calculate how long until I can destroy it. So what I mean by that, we're going to make a local variable of type audio source, new sound. And when we instantiate it, we're going to store it inside of this local variable. In other words, we're going to hold on to it. Essentially, we're going to spawn it and hold on to the thing that we spawned. So new sound is equal to instantiate, and then we need to give it a type of audio source if we're going to be able to hold on to it, which luckily this one up here is. So we can instantiate our shoot sound, spawn it at, I don't think it really matters since it's 2D, but we can spawn it at our transform.position. So the location of our player, and rotation, I mean, sounds don't really have rotation, so we can just say identity. Let's do a line break here, like that. Okay, so we're instantiating it, and we're holding on to it by referencing it with this new local variable. Now, we're spawning in the scene, but it never disappears. We're going to call a destroy method. So we'll say destroy, and we'll say destroy this audio source, this new game object that's spawned in the scene. But remember, audio source is a component, so we want to say new sound.game object, because we want to destroy the entire game object, not just the component. Otherwise, we have a lot of empty game objects floating around. We don't want that. Destroy the new game object that's spawned with the sound effect on it after, and we need to say, how long should I wait before destroying this thing? And we're going to say new sound dot clip dot length. In other words, however long the sound clip is, that's how long you should wait before you destroy it. All right, let's test it out. We're going to save, minimize, make sure that we plug it in. I don't know if I hooked it up. So we'll go player capsule, shoot sound. Remember, this is looking for an audio source, not a sound clip this time. Ready. Drag in, save, hit play. And I'm going to keep my scene view open so you can see what's happening. You're going to see it spawn particles and sounds. Let's see how they destroy. And we don't have any random pitch randomization or anything to our sound as well. Again, you can make this more complex later if you like. I'm just trying to get the basic prototypes. So the goal here is to make our shooting system communicate with our shootable script over here. In other words, if you remember, we open this up, all we really need to do is find the object, see if it has a shootable component on it, and then if it does, we want to call the shoot method. And then at that point, this thing can handle itself, right? Like it'll know whether it needs to take damage or whatever, because it's all plugged into here. But really all we need to do is make our Raycast detect an object, test and see if it has a shootable component on it. And if it does, then shoot it. So let's do that. We're gonna come over here. I find it useful to explain the problem that we're looking to solve first. So basically, I'm going to test to see if it has a shootable script on it. To do that, I'm going to say shootable, make a new empty container of type shootable. I'll actually call it a shootable object, to be really clear. And what I can do is I can actually use my hit info to get information about the object that we were hit. Remember, we got the point in which it was shot, but we can also grab the transform from the object that we were shot as well. Remember, if we get the transform of an object, so our enemy.transform, we can do a get component search to look for components on that object, which means we can search the transform to try to find if it has a certain kind of script. In other words, a shootable. So that's what we're going to do here. We're going to say shootable is equal to hit info dot transform, which is going to be a transform of the object we shot, and then we're going to search for a component on that game object dot get component. Then we're looking for a shootable component, close parentheses. All right, we'll do a line break here. So we're doing our search. We don't know whether or not we're going to actually find something, but if we do, so if shootable object is not equal null, in other words, we did find something, then we want to shoot it. If not, then we can assume that it wasn't shootable. It's just like a collider that, you know, we can put the sparks on it, but it's not meant to actually do anything in response. And so because we found that component through our get component, we can actually find that component and run that component's shootable.shoot, and then it'll handle itself. We can say shootable object dot shoot. Honestly, that's all we really need. If we shoot the object, then that's doing the communication. And now this shootable object is receiving the shot, right? Because we ran shoot, it's receiving the shot and then just doing its own things in response. And at this point, it's modular, right? Because we can put this shootable component on anything that we want to be shot by the player, and then we can have it do different things in response. Now let's just do a little test here though. Let's make sure that we're getting this far. So we'll do a debug.log shot. We're going to come back over here. We're going to remove our other one because we know that we're doing that now that we have the feedback systems in place. Come back to our shootable. If we see this, we know that the object with the shootable component on it is receiving the shot and can do additional things. So we'll test that out. Save. So we're looking for the shot debug. I'm going to clear it out, hit play. Okay. Remember, these things do not have the component on it. So we're not supposed to see the debug. But if we shoot the enemy, shot, 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 right? Then we know that it's working. And now we can receive the shot only on things with a shootable component. And remember, we can attach this thing to anything with a collider. So it's pretty modular, right? We can attach this to shootable wall triggers that open and shut a gate. We could have breakable barrels. We could have things with health. We could have whatever we want. And you could continue to expand on the system. So what I want to do next is just walk you through different examples of the types of things you can do with the shootable component and different ways to use it. Now, I'm not going to get, super fancy and do animations and things, but I want to show you the different ways in which you can plug into the shootable component to do what you like. All right, the first example we're going to look at is really straightforward. Let's say that I'm a level designer. I just want to quickly make things happen and put some barricades and be able to shoot them and go through. I don't want to deal with animations and particles and things. I just want to like test something out. You can actually control components through this Unity event. So we know that our shootable component is being called. So let's say my breakable wall over here. If I hit plus, I want to show you how we can use this. I'm going to drag in the same object that this wall is attached to into the object. Okay, so it's looking for an object in our scene. And then it's asking, what do you want to do on this object? So if I do this drop down, we can, run anything. We can change its name. That would be kind of wacky, right? We can do something with its transform, its collider. We could, if we had a rigid body, we could disable gravity. That would be crazy. But simply, I just want to do game object, and I want to do set active bool. I'm going to set it. I can either turn something on, like I could shoot a trigger and it would turn another object on. In this case, because I dragged the same object that the shootable script is attached to, drag that in, not checked is off, checked is on. I'm going to turn this object off, meaning when I shoot this object, it will run this and it'll turn itself off. Hit play. Shoot it. Cool. So you could actually have breakable walls, and you could make that fancier if you like. You could turn on lights, right? Like you could have a light in your scene. I don't know, point light over here. Call that door light over here. Where maybe it's off by default. I don't know. I'm just kind of like spitballing here, but you could add another one and just say, if I want to turn on this light whenever the door breaks. Oh, actually, in this case, our light is a separate game object. So we actually do want game object set active true. So turn off the door, turn on the light. Just to show you, you can do lots of crazy level manipulations just with this alone. See, like that. Enable, disable a bridge, whatever. So this is the first example of how you can just manipulate components in your scene. It's super handy as a level designer to be able to just drag and drop things, to plug them in and do things to components. I mean, a lot of which already exist. And just being able to turn on and off game objects has a lot of power in it. Our second example is, let's say, you want to do something a bit more customized and complex than just turning on and off components. Let's say you want to run a method on an object. So like collect this thing or perform this series of actions. Probably want to put that in code. I mean, that's the advantage and disadvantages of doing it this way, is you have to actually add some code. It's not just drag and drop. The advantage is you can get more customized and you can actually do more complex things. So let's look at how we can do that. On my breakable wall, I'm going to do the same exact thing. So I'm going to get rid of this story light. That was just to show you. So I'll do minus. I'm going to in code just turn this game object off, just like I'm doing right here. But I'm going to do it in code so that you could, crumble visuals, play sound effect, lock camera, screen check. You could do more things by calling this in code than I can with just, drag and drop in here. So I'm going to remove that. Make sure you remove it. And I'm going to make a new script. That's a disadvantage of this method, is you actually have to create a new script and, do more coding, which coding's fun. So you shouldn't worry too much about that. Create C#, and we're going to call this, I'm just going to call it what it is, breakable wall. Now, this would not be component-based design, but in this case, I think it makes the example more clear. Breakable wall, I'm just going to make a script called breakable wall. So inside of this script, make sure you attach it just like I did right there. Inside of the script, I'm going to make a method that I want to plug into this shootable Unity event. So whenever this thing is shot, I want to run this as a callback method, is what it's typically referred to as. So remove all this, say public void, and then whatever the name of the method is. I'm going to call this break. Make sure you press escape because you don't want that to autocomplete. Parentheses, brackets. I'm going to do the same exact thing that I did through UnityEvent. So game object, in other words, the game object that this script is attached to, game object.setActive, false. So this is just the line of code instead of the inspector, checkbox. But the advantage here is we can say to do add crumbly particles, to do add screen shake. Right, we could do a lot of other things here as part of a single method call, which is the power of doing it this way. But I did want to show you how you could call a method through code very simply and do additional things rather than just plugging 5 different things for each Unity event. So I'm going to save it, come back in here, hit the plus button, and instead of a component, well, that's still a component, right? In this case, it's just a custom script component. I want to drag in the script that I have right here. So drag in the script. You could also drag in the object too, if you like, and you could select the component over here. So you can see all the components that are attached to the object that you dragged in by unbreakable wall and say break. Now, as long as your method is public, you'll be able to see it in this list. So I'm going to select that break method. Just make sure that it is public, otherwise you won't see it. And now whatever we put inside of that method, we could continue to expand it if we want, will get called right there, So I'll do a, debug.log, break in the wall. There we go. Break in the wall. So we can save that. If we hit play, now we can run more custom stuff through code. So we can break the wall. We'll see it pop up in the console. Click over there and click back in. Breaking the wall. So that would be the second example, is you can create custom methods, maybe for level designers to hook into if you want to do more complex things. And you can call those methods through our shot Unity event. So you could have multiple different kinds of things in our level getting shot. You could have them each do different things once they're shot. So a little bit more power in the second example. You can do more things, but it does require more coding, and that has its advantages and disadvantages. Okay, the third way that I want to show you how you can use this shootable component. Let's say we want to apply damage to a thing. I may want to use parameters to pass things in. Now, I'm going to fix this example in the final one. I just really want to show it to you as an example. But let's say we want a health script and we want to, when it is shot, take a certain amount of damage. So first off, let's make a health script. I'm going to do a really quick one. So, you could reuse one that you already have. But I'm just going to make one real quick. We'll call it health. Let that compile. And we're going to attach this to our enemy. So we're on this other enemy object over here now. We're on our enemy. We have our health script. Let's see the things that we want in a health script. Very simply, again, this probably should be more complex, but we want a private int current health. And now we want to make a public method, just like we did before, that we want to plug in. So when this thing is shot, we want it to take damage. So we'll call it public void take damage, very simply. Here's the thing that I want to do though, is I want to pass in a damage amount. Now you may not always do it this way. This could be useful, being able to pass things in. So for example, let me show you, I'll call it damage amount. If I save this and I back out, you can see if I hit the plus button and I drag in my health like that, and I select take damage, so health, take damage, you can see I can give it a certain amount of damage to take. I can say take 21 damage every single time you're shot. Now, this does not account for things like, weapons with different damage amounts, which don't worry, we'll get to. But you could imagine being able to input different parameters being very useful. So for example, play a different sound effect whenever you shoot this trigger versus that trigger, right? If I shoot the lantern, I want to play a glass breaking sound effect. If I shoot the wooden crate, play the wooden crate sound effect. It's very useful to be able to change parameters for different types of objects when they're shot. So this is one example, right? Just to show you, you could pass in something that I would define as a designer. I could say, hey, enemy, take 1 damage every single time you're shot. Again, this is very simple. We probably wouldn't want to do it this way, but just to show you, this is how you could make it with parameters. Now, the reason is because the method that we're passing in actually has a parameter defined, meaning that whatever the designer puts right here, it's going to take that value, 1, and pass it down. So let's complete out our method here. We'll say when we're shot, we'll take damage and we'll take 1 amount. So current health minus equals, so subtract 1. And how much do we want to subtract is the damage amount. So I realized I'm defaulting to 0, which is going to give us a bug. So we'll say default to, 3. We're also going to need to come back in here and we're going to change the default before we forget. Designer says current health, you start off with 3. Okay, cool. So put 3 in there. Now, just for testing, we're going to say debug.log health remaining, colon. We're going to say append to that, just pass in whatever the current health is. So we subtract the amount, it's just going to be 1 in this case. Subtract it from the current health. Then if we wanted to get fancy, we could say if current health is less than or equal to 0, then we want this thing to die, right? And that doesn't exist yet, so we can make it. We could say public void die, and then just turn it off. Again, we could make this more complex later. All right. This is the most bare bones health script I can think of, but it works. So shoot it a couple times and it should die and disable. Remember, the way that we're setting it up now, it's always only taking 1 damage every single time it's shot. Maybe your game is so simple that that's all you need, right? Maybe you want to pass other kinds of parameters into this. You could have different kinds of parameters that are received, right? So you could have a audio clip or whatever. You could do that. Save that, minimize, come in here and we'll test it, play. Remember that we can still shoot our door, but now that door will behave one way, but our enemy will behave a different way, meaning health remaining 2, 1, 0. Cool. So you can see it's modular in that it's different, right? We can perform different actions on different objects, but the system hasn't changed. Our changes are only on a local level. We're changing it object by object, not our system every time we want to add a new object, which is terrible. Don't do it that way. But that's why we're building the system this way. All right, so the last example we're going to look at is how we can take our system and pass in different amounts of damage from the weapon. So up to now, we've actually been saying nothing, just, hey, you've been shot, without giving it any additional information. So our enemy knows, hey, I've been shot, what should I do? I don't know, I guess I'll take 1 damage. On an enemy by enemy basis, what we want to do is say, you've been shot and you've been shot for this amount of damage in our system. And whether or not it chooses to use that is up to the object. Like the breakable wall doesn't really care how much damage was done to it. Maybe you could do something that way, like if it takes a certain amount of damage, but you don't have to. The breakable wall, we could just say, hey, you've been shot. Here's damage if you want to know about it, but if you don't worry about it. You don't have to use it. But our enemy may want to use it and say, oh, subtract that much damage from my health. So in order to pass in the damage, instead of putting it in over here from the weapon, we need to make a couple of changes to our system, which is why I'm saving this for last. I want to show you how you could make this a little bit more robust. But if you don't need it, you don't need to worry about this part. So what I need to do is I need to actually pass in the damage instead of right here in the inspector. I need to pass in the damage from the player and long-term from the player's weapon. But for now, we don't have multiple weapons, so we'll just pass it in from the player. So let's change our system. Don't worry, it's not scary. We'll do this a step at a time. We're going to improve things, I hope. Alrighty, so to do this, we're going to come back to our use shoot script. We're going to add a damage amount. So we're actually going to keep the same amount of damage. It's still going to do 1, but the point is you can change this. You can pull this from the weapon. You can make it bigger. You could, level it up, whatever. However you want to get the damage is up to you. But the point is you need it to exist somewhere so that you can put it into your shoot system. So for now, I'm going to just keep mine right here. Damage amount. All right. So we're going to scroll down. So we need to make 2 changes here. The first change is that we want to pass our damage amount into our shoot. So if we go back to our shootable script, we're actually calling shoot on the shootable component, right? We want to receive an amount on this parameter. So I want to say shootable component.shoot and receive an amount. So we're going to say int damage amount. Now, the other thing is when we pass in this parameter, we need to be able to pass it in from the other end as well, meaning that our use shoot needs to pass in a damage amount. So we're receiving a damage amount. We need to pass a damage amount. We're just going to pull that from up here. So damage amount, copy that in, paste it in. Okay, shoot that object for this amount of damage, which we were saying is, well, right now it's 0. So we'll just say it's 1. Again, you could pull that from a weapon. You can expand on that. Shoot damage amount, save our script, come back, receive damage amount. And now we actually need to pass this damage amount into our Unity event. So the question is, how do we do that, right? Like, how does our enemy over here that is trying to determine how to subtract damage from its health, how does it know how much damage it was shot with? Well, we're going to put that in the Unity event. So you can see right here, this is, there's nothing here. I'm going to come up here and I'm going to add a type to my Unity event. To do that, it's going to be open, less than. I type in the type of the parameter that we're receiving or that we want to pass through. Type of int, close, just like that. So open int, because we're passing in a type of int, close. Remember, make sure that you keep all of your parameters the same. All right, so we have our shot. Now, when we invoke our Unity event, we want to make sure that we pass something in, right? It needs an int in order to pass it out and broadcast that to all the other things that are listening to the event. So this is saying, everything, you've been shot, and this is the amount that you were shot. So I'm just going to pass in a damage amount. It's maybe a little bit confusing. It definitely is. This is how it's working to the best I can explain it. Invoke the Unity event using a damage amount that is of this type. And if we do that, if we save and we come back over here, you can see now when we're shot, it says int 32, meaning that if we plug something in, we can get access to the int 32. Now, here's the thing. Our take damage event receives an int damage amount, but when we plug it in this way, like through the inspector, it wants the designer to input everything. But I don't want to do that. Check this out. I'm going to remove this. What I want to do is, in this fourth example, or expanding it, I want to connect my take damage event through code instead of through the inspector. Because if I do it through code, then the parameter is passed automatically in instead of being passed by the designer putting in a value, which is the more complex way to do it. But the advantage is we can receive that damage amount. So let me show you what this looks like. I'm going to connect my take damage method to my Unity event, but I'm not going to do it through the inspector. I'm going to do it through code. Let's take a look at what that looks like. So I'm going to go to my health right here. You have multiple ways of doing this. You can either do an inspector reference or you can do a get component search. I'm going to do an inspector reference just so you can, very clearly see where the dependencies are, but you could do a get component search if you like as well, as long as you're strict about it, I guess. All right, we're looking for a type of shootable component. We'll also do private, just be proper, save this, meaning that it needs a reference to the shootable component that you want to plug into this. So like that. I'm going to drag and drop this component into here. Now my health is going to look at this shootable component and subscribe to the shot event that's inside of it through code instead of through the inspector. So I want to show you that you can do it both ways when you're using Unity events. So anytime we subscribe to an event or unsubscribe to an event, we want to do that through onEnable and onDisable. There are some exceptions to that. I'm oversimplifying, but if we say void onEnable, and we'll do private void onEnable, onDisable, we want to try to avoid listening to the event when this object is disabled because it's not really active, and that can get kind of confusing. So on enable, we want to, I'm going to type comments out here, watch shot event, on disable, stop watching shot event. And the code for that is shootable. And we're going to look for the Unity event. So shootable dot, I think it's just called shot. Yeah. And then in order to hit the plus button and add this thing through code like we would with the inspector, we access that Unity event inside a script. So like we're accessing this right here. We're going to say dot add listener. That's the equivalent of hitting the plus button in the inspector, pretty much. And we're going to say take damage with no open close parentheses, just like that. Now the reason why we can do this is because our take damage receives the same parameter that is defined over here. Remember when we did that little type, this type? This means it needs an int parameter. And because this has an int parameter, or the thing that we want to run in response, it'll just pass it straight through. So check this out. If I were to remove this and save, you see how it would not let us auto add our listener? It's because the parameters need to match. So be aware, if you do this through code, the parameters need to match with the type that we did earlier. But it should, if you've been following along. Just saying, if you do this through code, you need to be better about that. Then in the inspector, you can just kind of override it, I believe. All right, so now we also want to unsubscribe. .shot.remove listener. Take damage. Now the other thing is, if we wanted to be really proper about this, we'd say if shootable is not equal null, meaning that if the designer did not, drag in the dependency, it won't break our code. Say if, we'll just copy paste this. Copy pasting is bad. There we go. Oop. Pull that in the brackets. Okay. On enable, if it's not empty, add listener. On disable, remove listener. And we're doing the same thing we did before, right? Like add remove, but we're doing it through code, which remember, the advantage is we can pass in that damage amount automatically without defining it on each object, which is what we want. So what should happen, let me do a final run through of our logic here. On our useShoot, we are defining a damage amount on our useShoot. we're taking this damage amount, and when we shoot an object that is valid in our layers, we are looking for a shootable component on that object. And if we find it, we're running the shoot method and passing in our damage amount, right? Our damage amount on our shootable. Because this was just run, we received that 1 damage. We print a debug. I don't think we need this anymore, so I'm going to get rid of that. And if there are things subscribed to our Unity event message, meaning things that are watching to see if this thing has been shot, they will react, right? We're going to invoke our event and say, everything that's watching, I want you to react. And also, if you want to know about it, this is the damage amount that we were shot with, okay? So then our Unity event over here on our enemy, it has now been activated. We could plug in additional things in the inspector if we want, but instead of doing that, which the breakable wall is doing, right? Instead of doing that, we're taking that damage amount, and our health script is watching whether or not that thing was shot. And when it is, watch to see if this thing is shot. Add listener. So listen for it to be shot. When that thing is shot, run this callback method called take damage and pass in through our parameter the amount you were shot with, and then basically do our normal stuff. Let's test it out. Hit play, click in, shoot our wall. Cool. 2, 1. Okay, cool. Now, to prove that this works, we're going to change the damage amount. Remember, only change in one place. Change in our use shoot, and you could, again, pull this from a weapon or whatever. We're going to make our damage amount 2 instead of 1. Save it, hit play. So now it should drop in 2 points. 1, dead. Cool. So I know this is complex, like in terms of setup. Once you have this built, all you need to do to make something else shootable, check this out. Let's click on a random box. We'll do this box over here, and we're going to attach our shootable component. Cool. And then we're going to make it disable itself. Turn the game object off, set active, false. See that? If I shoot this box, it should disable. Hit play. This is how quickly you can reuse a shootable component. I know a lot of this was building it from scratch and setup, but check this out. See how quickly you can create game mechanics. You could hit a switch and it activates a door or a bridge, or play sound effects when you shoot something, change material. You could do so much with this. And that's what I encourage you to do, is like take this and build on top of it, right? Like continue to build your weapon systems and so forth. All right, so now I know this is a really long video, but I tried to put a lot of interesting topics in there, and I tried to give you something that in the end, it's not just for a tutorial. Like you can actually take this and use it for your game and build it, and it's more designery than a very static, technically it works kind of thing. So let's review all the stuff that we learned. We did learn briefly how we can create our weapon visual and our socket system, right? Like that's pretty useful, how we can potentially make different kinds of weapons and position them on a socket so you could swap them out if you like. Using the new input system, we created a new shoot action and built that on top of the existing FPS controller. So we didn't have to build a new FPS controller. We're just adding functionality on top. So we made this new component that is doing raycasting. It is spawning particle effects inside of our scene, so spawning them and destroying them. We did the same thing with sound effects, so shoot sound, so we have our audio-visual feedback. We did some layering. We did the more complex version of our raycasting where we tested layers, we calculated the length, we did our debug ray, and then we are communicating with another object. We're finding the other object, we are testing if they have a shootable component, and if they do, we are making things happen. We created this other shootable component that we can attach to anything. It's using a Unity event. So we learned about Unity events, and then it's triggering that through code. And then we can just plug anything we want into it. And so it's very modular. And then finally, we looked at a lot of examples on how we can use this. We can just manipulate components. We can run methods, right? We talked about our take damage method or our breakable wall method. And then lastly, we did the more complex version where we made it a little bit fancier and we passed in the damage through the shoot method, so that we have options. We can either make it take 1 damage by hooking in this way, or we can plug it in directly by adding listeners and subscribing or unsubscribing through code. So I hope that you get a lot of options for how you can use this thing, and you could customize this more if you want. But I really wanted to show you how you could take the existing default FPS controller and start to build something cool out of it, start to create your own games. You could take this, instead of shooting, you could make a separate action for like interacting with doors when you press the E button. You could do a lot of different things. So hopefully you learned a lot here, and hopefully you have something to start to build a game with.